and click. Still don't have a camera. Maybe pop out, pop back in, give that a whirl. Also, everybody, listen. One thing that has really helped classes with cameras is to go to the three little dots in the lower right-hand corner, go up and make sure auto adjust and apply bandwidth are not selected. Okay. Hey, there you are, Ava. I see something. Maybe it looks like you need to turn your camera on. I mean, not camera on. Turn a light on. Oh, no, there you are. Hey, I see you. Nope, you're gone again. All right, here we go. So, everybody, let's see here. Let's do this. Tell me what has to happen to sea levels to get a beach environment. What do you think? Sea level must be what? Almost gave it to you. Good. It receded. It went down. Thank you. It lowered. Okay. Good. Well, what about shallow seas? What does that mean? My husband just brought Go-Go Juice of Life. Got a little Dunkin' Donut action this morning. Mocha coffee, no cream, no sugar. Delicioso. Good, it has to go down, right? Yeah, sea levels have to go down. All right, how do you get from limestone or sandstone to shell where it says deep sea? What has to happen then? What has to happen then? How do we get from limestone to shell? It forms in deep sea. Sea levels have to what? Come on, guys. Has to rise. Yes, it has to rise. So even in our example, you're going to see this. Sea level low, sea level rise. Sea level low, sea level rise. Okay? It falls. Hey, Jarius, welcome to class. Glad you could be with us this morning. Good. Y'all are not seeing my screen, are you? Nope, you are sure not. All right, this is what I was looking at as I was typing in it. There you go. That's what you should be looking at. All right, so sandstone. Yeah, that one. Sorry, my bad. Sandstone, we're looking at these symbols. Sea level has to lower. That's near shore. Limestone forms in shallow seas. Sea level would have to lower. Shell forms in deep seas. Sea level would have to rise. And if you got that, you got the first part over here anyway. Okay. All right, so be ready to participate in the chat. Here we go. Working on the example. Maybe if I get my treadmill back. Here, which one of these came first? Which layer? Looking at these three layers, there's the Coconino sandstone, the Hermit shell, and the Esplanade sandstone. Which one came first? Which one is the oldest? The bottom layer. I like it. Good, good, good. The link should not be taking you to Microsoft. I don't know why that would happen, but if it is, go ahead and download it as Microsoft Doc anyway. You can do it that way too. Good. The layer at the bottom, right? As we dig deeper, the layers get older. So the Esplanade sandstone would be the original layer here. What has to happen to get sandstone? I mean, you can read it off of there. Yeah, I get it, but I do want you to participate in the chat. What has to happen to get that sandstone? Sea levels have to what? Hey guys, this is either a 30 to 40 minute task or it's an hour and 15. I had two classes do it in 30 to 45 minutes yesterday, and I had one class that took an hour and 15 because they didn't participate. What has to happen with sea levels? They have to go down. Good, there we go. Yeah, so sea levels have to lower. The esplanade sandstone is deposited in a beach environment. Okay, good. Now, go ahead and train yourself, train your mind to notice this. See this squiggly line right here? That squiggly line means that there was something that disrupted this layer. That something, hey, Kimura, welcome to class. Please turn that camera on for me. That something is called erosion. All right, so anytime you see a squiggly line on our cross section today, know that it is erosion. Okay, now, what do we know about sea levels if we have shale that comes next? Shale comes next. What do we know about sea levels? Good, it has to rise. Thank you, Ava. Hey, Kimura, please go up to the top of the chat. Jarius, I know a couple of you just popped in. Go up to the top of the chat. If you haven't already, make sure you have that document. Remember, class begins at 8:30. Okay, so if you come in 10 minutes or more late, you'll get that email at the end of the day. All right, everybody good? Okay, hold on, Kali, Maddie, or Madison, sorry. I need to make sure you two have this document. Okay, there's nothing wrong with the document itself. Like, there's no reason for you to, and also there won't be a recording on this yet. Okay, so you need to make sure you're doing it with us. So how can I help you get to the document? Because I see lots of your classmates already in the document. So I know on my end it's good. If you have to click, you will have to click File and make a copy of it. Do you need it again? Because before I begin the actual work, well, do you think it's a leave and come back thing? Like it's like you're running slow or something? Yeah, that's fine too, Jason. You can absolutely, also, but you clicked on the link, right, Jason? So when you get in it, that's okay. That's okay, Madison. You can still type in it, right? Okay, perfect. All right, yeah, Kali, if you think you're moving slow and you want to try to pop out and pop back in, it's fine. I just don't want you to miss the next part. If you want to, some people prefer to do it that way. If you click File, make a copy, that's fine. You could click Save as a Google Doc and go to it other ways, or you could click Download and go to Microsoft Word, and that downloads it directly to your computer. Okay. Some people like to keep it on their computer rather than in their Google Drive. All right. So there's multiple ways to get that there, but you do have to be logged into Google. All right. All right. Hopefully everybody's with me. Continuing on, how do we get to shale? What do we know about shale? Okay, glad you're here, Kamor. What do we know about shale? Let me pop back over here. What has to happen in order to get shale? Anaya, I need to see you in the chat. Jaden. Kane, I need to see you in the chat. Very good, Jaden. It's deposited in deeper seas. That's exactly right. So sea level's good. You two, look, there's my point right there. That's beautiful. What you just did was beautiful. Hey, Kylie, glad you're here. Remember, class starts at 8:30. What Jaden and Bowden just did together was absolutely why we're doing this. Jaden says it's deposited in deeper sea. Yes. And Bowden said sea levels rise. Those two answers together are the answer. Okay. So sea levels have to rise. And then that hermit shale is deposited in deeper seas. Well, what has to happen between shell and sandstone, the Coconino sandstone? Sea levels have to do what? Kylie, that's up at the top, or the document's up just a little bit. Yep, good. It has to drop. That's right, it has to drop. Sea levels have to drop, returning it to beach, and then giving a sandstone. So we do that in a large part of this cross section that we're talking through, okay? But that's just the example, okay? I went ahead and cut this one down. It is at the bottom of your document. So if you scroll all the way down to your Interpreting Geology lab, that cross section is down there, okay? And so is the symbol chart. So we are working on number 1. So please put your cursor at number 1 and letter A. Give me a thumbs up when you're there and you're ready to move. All right, Dakota's the only one. Where's everybody else? Give me a thumbs up when you are at number 1, letter A. There we go. Sorry, I don't mean to be munching in your ears. Jason's ready to go. Kane, are you with us? Asma, are you good? Yes. Okay. Anaya? Oh, yeah, Jaden, definitely redo it. Definitely. If you haven't done it with me, I would not turn in what you did. And that's not because I think you can't do it. It's because the way I walk you through this, what I'm expecting from this lab is way, way more than most people would do on their own. Okay, Kane, you don't have the correct document then. And you could do it on the other doc, that's fine. The one from the content. But I added a lot more to this doc to help you out. All right, Kimura, are you there? I haven't heard from you. Kylie, did you get the doc up? Asma, are you good? You got the doc? You ready to go? All right, let me know, Kane. All right, number 1, letter A. Here we go, rocking and rolling. We have to start, like you said, at the bottom. So, and remember, I'm not going to give you these answers. You have to work together to get them, okay? Oh, awesome, Cully. I don't see you back in class yet, but that's so weird. That's happened the past 2 days. People are commenting in the chat, but they're not in here yet. Oh, there you go. You don't need to request edit. Okay, this is exactly like the last couple times I've sent you a doc. You don't need to request the edit access. Just click File and make a copy. All right, I'm moving. Hopefully everybody's with me. What is the first layer? Somebody tell me in the chat, what's the first layer? And I expect lots and lots of. Okay, Kane, remember last time your dad's Google Drive was full? Man, you got to figure out this Google Drive. We talked about getting your own Google Drive so that it was free of stuff. Okay, perfect. Yeah, I see lots of correct answers coming in the chat. That's perfect. That's right. The Vishnu schist. That one's first. The Vishnu schist. Good. That's our foundational layer, our original layer. We don't know anything beyond that. That is the bottom of the Grand Canyon. Okay. What would be on top of that? So for A, you would write Vishnu schist was deposited. That's easy, right? Vishnu schist was deposited. That would be A. Everybody good to go to B? You've typed in Vishnu schist was deposited, and we're ready to move to B? Yes. Good. Speak now, forever hold your peace. Yes. All right, good. B. Now tell me what happens. What intrudes on top of that Vishnu schist? I don't know what that means, Ava. Oh, good. See, yeah. Okay. So I like, Ava, I like that you are so willing to just put your answer out there and not even think about it. I love it. Okay. Jalen, thank you. You would think because the limestone here is on top, right, in order that it would be next, but that's not right. Good, Dakota. Yeah, good. Awesome. So we have an intrusion, not a normal, hey, Jay Sean. Okay. If you're having tech difficulties, you'll need to send that off. You'll still get the email at the end of the day. Make sure you send a note, a parent note to CASC attendance, okay? All right, so we are working in this lab, and we are already on B. Maybe one of your classmates will tell you what to write for A. That would be awesome of you. So we have an intrusion here, okay? Not layer after layer after layer. This is an intrusion. It's called the Zoroaster granite. We know that that Zoroaster granite, if we go back over here to granite, right? We know that it formed because the rocks were melted and then recrystallized. Okay, so B then, from what you just told me, B would be Zoroaster granite intrudes on the Vishnu schist by melting and recrystallizing. So you said what came into play and the environment in which it formed. Ooh, I put my protein shake down in this coffee, y'all, and it is good. All right, so we have a couple of classmates that need help. Tell me what you put. What'd you put for B? Thank you, Jaden. Zoroaster granite intrudes on Vishnu schist by melting and recrystallizing. I love it. If you're struggling, copy that answer and paste it in B. Jaden, you're on point. Jay Sean, I still can't see you. Can you either, it looks like you're maybe, oh, maybe I do see you. I don't know. Can you turn a light on? I think you're there. I can't tell. All right, are we ready? Ready to move? Okay, need another minute? Jay Sean, you need a minute to get a light on, or you need a minute for me to wait for the material? Engagely's being kind of funky today, huh? Okay, I'm going to move then, Jay Sean, for everybody else. What comes next after the Zoroaster granite? And I have a feeling a lot of people are going to say the same thing here. What's up? What's next? What's C? Oh, the limestone, right? Good. You didn't fall for it. A lot of people say the igneous intrusion there. And that would be incorrect, right? That would be incorrect because we could see that that igneous intrusion comes all the way up to the Hakatar shell. Good. The limestone is the next layer. However, we're missing a little something. What are we missing? Well, that arrow's not really that great, but what are we missing? Come on, you got this. What does that line right there look like? We had one in the example. What did that squiggly line mean? Ah, good, Jaden. Yes. Yes, it means erosion. So, okay, first we had erosion. That erosion had to come before that vast limestone. All right, good. So, good. Number 3, or C, would be erosion of the limestone and a little bit of that granite. Erosion of the limestone and granite. Yeah, something funky's going on. Everybody's camera just went out. Still there? Hello? Where did my children go? All right, looks like you're still here. Just there's no camera on. It's okay. And again, Engagely is being really funky right now, but I'm going to continue as is. Just please make sure you are lighting that chat up. Stay green, okay? Anaya, I need to hear from you. All right, so we have erosion of the limestone and the Zoroaster granite. What comes after that? Now you would be correct in saying what comes next? The limestone. Good. The Bass limestone was deposited. And what's that environment like? Coming back to this, what's that environment like? The limestone. Good. Good. In a beach environment, shallow seas, fine. That's the same thing. Beach environment, good. Right. Okay. Now, like the example that we did, now we have to talk about sea levels. Up to this point, we have had no signs that this area has had water. But now with the limestone, that tells us, hey, water came into the picture here. It's probably what caused that erosion. So now we have the Bass limestone that says, hey, water is on the scene. How do we get to shell? How do we get to that Hakatar shell then? And we're halfway, guys. Just so you know. How do we get to that shell? It has to rise. That's correct, right? So what you're saying in the chat is sea levels rise, Hakatar shell is deposited. There you go, Kane. Good. In deep water. That's exactly right. You guys are doing a really great job of piecing this together as a team. I love it. Okay, so A, B, C, D, E. Sorry, I have the numbers and not the letters. E should be sea level rises, Hakatar shells deposited in deep ocean. Everybody good? Everybody ready to go? Yeah, we did D. D was the deposit of the Bass limestone in shallow marine life, or shallow marine. All right, Kimura's ready to go. Hey, guys, I can't see your faces anymore. Yeah, I know. Carly, Engagely's being funky right now. I can't see anybody's face, so you'll have to give me the virtual thumbs up because I can't see like your eyes. You're shaking your head. Yes. So you ready to go? Everybody ready to go to the next one? Yeah, I think everybody's is loading pretty slow. Somebody want to help Kali out with D and E? I would really appreciate it. All right. Holler at me if you need me to slow down. I'm just moving forward. This kind of bugs me that our technology is not working, but it is what it is. All right, awesome, Jalen. Thank you. Thank you, Madison. Thank you, Kane, for helping your teammate out. I appreciate that. All right, so we had the Hakatar shell was deposited, deep ocean. Now here's something different, okay? And this is really why you need to walk through this with me, all right? This next part, we don't see quartzite in any of this, right? If I go back over here, my bad, y'all. I don't see quartzite, right? How is quartzite formed? I don't know. You would have to Google it, right? And the weird thing is that quartzite is a metamorphic rock. But its symbol, yeah, you're right, Kane, but its symbol says sandstone. And here's what happened. Okay, here's what happened. In this picture, we can see that it used to be sandstone. Okay, it used to be sandstone, but something happened. There was intense pressure at this time. This layer was deposited, and now it has become a metamorphic rock. Its structure has changed. Sorry, y'all. Goodness gracious. Its structure has changed, and now it has become a metamorphic rock. That tells us something very, very, very important, but I'll get to that in a second. We are going to treat this like Amarian. Hey, Amarian, we are working through the lab. Dude, our class starts at 8:30. You missed a bunch, man. Please make sure you're muted. We can hear what's going on your end. All right, everybody. We're going to treat it like sandstone. So how do we get from shell to sandstone? How do we get from shell to sandstone? Shell to sandstone. What do you think? Tell me in the chat. I keep trying. How do we get from shell, which is deep sea, to sandstone, which is beach? What has to happen to those sea levels? Good, they have to lower. Good. So we say here that good, the water recedes, you can say that, the water drops, that's fine. But here you have to say sea levels dropped and Chinoomo quartzite was deposited. Okay. And we're almost through the hardest part here. And still, none of your cameras are back on. There they go. Weird. I can see everybody now. I can see you. Thank you. That was weird. All right. Then what has to happen? What letter are we on? Anybody want to tell me? A, B, C, D, E, F. So we should be on G. Yeah, okay, I see you. Good. What happens next? Be careful with this one. What happens next? Listen to things without words? I don't know what that means. I'm saying words. All right, Kane says erosion. Yeah, you might think that. Okay, you might, right? But we missed a little step there. It's hard to see. Dock sandstone, good. That's right. Dock sandstone, Kane, we know that that dock sandstone was deposited first because the erosion includes the dock sandstone. Okay, so dock sandstone came next. So G would be dock sandstone, again, deposited in a beach environment. Okay, Kali, just do your best. Yeah, I'm not really sure how to help you with that. I mean, I'm giving the answers, typing them out as we go. Yes, you'll maybe if the recording posts, you'll go back to that. All right, Kane, then you said erosion occurs, right? Erosion occurs. All right. That is true, but something else happens first. Something else happens first. Tell me about these layers. Make an observation. Anaya, I need to see you in the chat. Bowden, I haven't seen you in a while. Jarius, I haven't seen you. Jay Sean, I need to see your name in there. Something else happens first. Make some observations. Does this bottom half down here look like the top half? Does all of this look the same as this up here? Is it all nicely layered on top of each other? How does the layers, how do they look? They look like they've been what? Okay, stacked, yeah. Maybe kind of differently. They look compacted, you said. Okay, keep going. They still look layered, yeah. But how are they shifted? Does that look the same as the top half? You think they look organized, really? They look as organized as the top half? Tell me about this bottom half. What do they look like? Are they at the same angle as the rest of them? Keep trying. Ah, good. Madison, that's exactly right. They look tilted. That is the exact word that we need to use, okay? These underwent intense plate tectonics, all right? We know that for a couple of reasons. One, what we're going to have next is we have this igneous intrusion. That means there was intense plate tectonics during this time. and it pushed that magma up through that crack in the crust. Okay? The next thing that tells us is this quartzite. How did that sandstone become a metamorphic rock? Because at this time of this tilting, it was under intense heat and pressure. Okay? So two things tell us about this plate tectonics right here. Three things, really. The organization of those layers, the tilt of those layers, the igneous intrusion, and the sandstone to quartzite right there. So what are we writing then for, what are we on? H, yeah. For H, you would say plate tectonics occurred tilting the layers, and then add in what Kane said, and then the erosion occurred. So the tilt had to happen first, and then the erosion. So the tilt occurred, and then erosion. Intense plate tectonics caused the layers to tilt, and then erosion occurred. All right, everybody ready for I? We have some unfinished business down here in this bottom part. What have we not identified yet? What have we not identified? We haven't written down yet that exists down there. Hello, Nathan. Welcome to class. Nathan, our class starts at 8:30.
I'm sorry. I thought it was.
All right.
I thought it started later.
Okay. Good to see you. Can you turn your camera on for me, please? Yes, y'all are getting it. Yeah, the igneous intrusion. So I would be igneous intrusion. That's where that magma is pushing up through the cracks because of the plate tectonics at that time. Omarion, you did not think it was 9:15, buddy. That ain't gonna fly with me. You have been in this class for what? How many weeks now? You know this class starts at 8:30. It's on your schedule. Set an alarm. Get here at 8:30. Okay? Don't you be telling me no 9:15. Boy, you know. Come on now. Hey, Nathan. Cameras are a requirement in my class. Also, you need to be in the camera, and it looks like you've got it covered. Or it's really dark in your room, so if you could just go ahead and turn a light on or something. Get that figured out. Thank you. All right, I is the igneous intrusion. Now we're moving on. A, B, C, D, F, G, H, I, J. J. What comes next? After all that, now we're down on the downhill side. This is the easy part, right? Anaya, can you reach out to me in the chat, please? The downhill side of this. What comes next? I'll wait. What comes next? Anaya, can you reach out to me in the chat, please? Good. Jalen says the limestone. Limestone. Yeah. Here's a problem. This is an error. Okay. This is not actually limestone. The symbol is correct. It's supposed to be sandstone. So that's an error in the lab itself. It should be T-Peats sandstone. Okay. Right. So Anaya, I'm going to wait about another minute and a half. I need a response from you in the chat, please. The T-Peat sandstone would be next. And in what condition does that T-Peat sandstone form? In what environment? Good, good, good. Beach. Yeah, shallow. You could just say shallow seas. So that's fine. Shallow water's fine. That's good. Anaya, still looking for your chat. Good, good. J. Yep. T-peat sandstone was deposited in a beach environment. Almost there, guys. All right, now we have the setup like we had in our warm-up, right? So now we have limestone to shell or sandstone to shell. How do we get from sandstone to shell? What has to happen to that water? Yeah, I was igneous intrusion. What has to happen to the water? It has to rise. Yes, it has to rise. Good. So in order to get that shell, we have to say in K, sea levels rise, and the bright angel shell is deposited in deep ocean. Nope, we just finished K. Good. Kimura, you still with us? Maybe somebody can help you out, Ava. Follow along. Your teammates need some help in the chat. J was the T-peat limestone or sandstone beach environment. K was sea levels rise. Bright angel shell is deposited in deep ocean. L, let's go on to L. What has to happen between the shell and the limestone? What has to happen? We're working on L right now. What has to happen between the bright angel shell and the mauve limestone? Yeah, Omarian, I'm not going to give you A through J, baby. That's not happening. You'll have to go back because you were almost an hour late for class. You'll have to go back and watch the recording to get the answers. I'm not going to give you the answers. You'll have to actually do the work, okay? Yeah. I mean, just point blank, guys, like, if you don't do the work, you're not going to know the material. Just getting the answers to get the grades not going to help you on the test. All right, good. Kane says sea level has to lower. That's correct. Sea level goes down. And we get, for L, we get the mauve limestone. Sea level's lower. Mauve limestone is deposited in shallow marine life. And I feel pretty good that most of us can stop at this line right here. Tell me what that means. What do you think? Tell me what the line means. Wiggly line. What does it mean? Erosion. Good. Thank you. Good. Erosion. All right. So you should have A through what? M? A through M complete at this time. I'm going to leave you to do number 2 on your own. Okay? So over here, you just completed number 1, and that was starting at the Vishnu schist and coming up to the limestone. Okay? So I'm going to leave you to do number 2 on your own, but I am going to give you some examples. All right, I need you to find each of these these unconformities, nonconformity, disconformity, paraconformity, angular unconformity. So big words that means simple things, okay? Big words that mean simple things. All right, I hope you're paying attention to this part because you're going to have to do this on your own. Anywhere you see that squiggly line, you just told me a place on there. Anywhere on that cross section that you see erosion would count for disconformity. Guys, M was sea level lowers. Limestone, the mauve limestone was deposited. Oh, that was L. M was, let's go back. M was the erosion of the limestone right there. That was the last one. All right, so for number 2, what you're doing is you're finding on this cross section these different types of conformity. So you need to say between mauve limestone and bright angel, or the Unger group, or between the Vishnu schist and the Zoroaster granite is where you'll see these, okay? So the disconformity is any erosion. Any line on there that's squiggly, you might say the Zoroaster granite and Vishnu schist. That's where you would find erosion of those two. That's where you would find disconformity. Nonconformity would be any intrusion. That's a key word, right? So we have 2 intrusions right here. Igneous intrusion, Zoroaster granite. Those are both intrusions. Okay. And then we have paraconformity, which that's the nice, seamless, nothing in between, perfectly beautiful, lined up layers. And the last thing is angular nonconformity or unconformity. And this one's super easy. There's only one, right? That's anywhere where you see the land has been tilted. All right, guys, this is all you have to do for me this week. If you have questions continuing through tomorrow, feel free to shout out to me, send me an email. Again, I'm not going to do the work for you, so I'm not going to just give you a bunch of answers. But the other set of kids, my other set of kids for Tuesday, Thursday classes, they have an extra day with me on this lab. And so if you are stumped, I will gladly help you find the answers, okay? But no, I'm not going to just send you the answers to A through whatever. No, you don't need to do N. I left it on there just in case, but I feel pretty confident y'all know what you're doing at this point, okay? All right, so all you have left to do for me is number 2. And this is due tomorrow. This is not tomorrow, sorry, Friday. There we go. This is due on Friday. So I'll give you a couple days to finish it up, check over it, and then answer number 2. Okay? So everybody, this is due Friday, and your unit test is Friday. And what I'm going to do here in a little bit is I'm going to send out some practice for you to complete before you take that test, okay? All right, if you don't have any questions for me, y'all, I hope you have a wonderful day. Get your work done. See you next week.